a request to all the delegates to please settle down so that we can start the session dot at 4 p.m. We'll start in another 2 minutes. One more minute to go and we'll start. We are starting the webinar now at the count of 3, 2, 1. A very warm welcome to all the delegates who are attending the episode 5 of the season 2 of the IWET series. My name is Kailash Shirodkar and I'm the publisher for Smart Water and Waste World. And I would now like to quickly, thank some of our speakers who have taken time out early morning from Canada. And I'm sure that we are going to have an interesting session today, as we have for the last 4 episodes of season 2. To start the session today, I would now like to invite Mr. Ravikant Tiwari, Trade Commissioner, Ontario. He is based in Mumbai, and he's going to talk about the Ontario, Canada, India water technology collaboration. Over to you, Ravikant.
Thanks, Kailash, and the entire Smart Water and Waste World team for organizing excellent IWET series of webinars for water sector professionals. It's my pleasure to be here. Again, I'm Ravikant Tiwari. I'm the Trade Commissioner of Government of Ontario, Canada in Mumbai. While many of you may be familiar with Canada and opportunities it has to offer, at high level, since you have been hearing my colleagues and this is the 5th episode, allow me to share few perspective and provide a profile of our province within the broader Canadian context. Ontario extends from the mineral-rich north to farms and vineyards of south, pierced by the dense urban corridor that runs east-west along the United States water, like the freshwater Great Lakes that shape our border. We are big. We are bigger than Texas and more than double the size of California. The province of Ontario is also considered the economic engine of Canada, and 40% of Canada's population and economy. Ontario is the leader in wide array of industries. Opportunities for growing commercial relationship between Ontario and India are boundless. This is why Ontario has chosen to operate 2 offices in India. One is located at the High Commission of Canada in New Delhi, and another one at the Consulate General of Canada in Mumbai. Ontario, Canada, is a global R&D leader in water technologies. Ontario water companies have made clean water a reality in some of the world's toughest industrials and urban environments. Many of the biggest breakthroughs have come from Ontario, Canada. In fact, 2 of the most widely used technologies, US disinfection and membrane filtration, were developed in our province. And we have raw from Ceres, BioSystems, and Meni from TradeWorks, Environmental Incorporation from Canada today. They're going to talk about the technologies, from our province. And we also have one more company from British Columbia, Pani Energy. They would also be sharing their perspective and the technologies from Canada. So overall, more than 900 companies, 100 technology incubators, 22,000 water industry employees, 42 Canadian research chairs make up the Ontario water innovation ecosystem, contributing to its ability to develop a world-class water technologies. I have few more names. Some of you may have already heard from one of our Ontario companies, Clearford. It has presence in India. We also have Trojan Technology, a global leader in UV treatment. They also have a significant presence in India. And there are some companies which are lined up, AUG Signals, which provide real water monitoring. We have New Terra, which provides containerized water treatment solution. UV Pure, who water treatment technology is used in Boeing, the 747s of the world. So we have these companies lined up, and we are exploring opportunities in India. And in terms of our government and our Canada, Ontario, Canada, and India water collaboration, we can provide, our companies can provide the niche services to smart cities, the development, especially for water and sanitization. And this sort of engagement basically requires government to government collaboration. So here the companies which are present from Ontario today, I would like to share that we already have 5 MOUs with the state governments in India, and we are developing our partnership with Karnataka and Maharashtra further to include the infrastructure and water sector in our collaboration. And since we have some of the Indian companies as well present today, I would like to share the message. Our central's message is that we are open for business. Our government is looking to reduce business cost, cut red tape, operate operations, and as our minister calls it, the speed of business. Again, I'll not take much of the time. And in closing, let me thank once again the team Smart Water and Waste World for inviting me to join today's event and share some of my perspective from province of Ontario. And I hope some of the high level context I have shared is helpful in setting this stage, what I'm sure is going to be insightful discussion. So please do not hesitate to get in touch with our offices if you're interested to learn more. Thank you very much once again, Kailash, for this wonderful opportunity.
Thank you, Ravikant, and I'm sure that the attendees would benefit a lot from learning what the expertise are there, one with the Canadian companies and specifically from Ontario. So, looking forward to some, wonderful sessions going forward. So, coming to our next speaker, and before I do that, I would like to request all the attendees that if you have any questions, please put them in the Q&A box at the bottom of your screen and not in the chat box, because then it's easier for me to choose the questions and address it to the respective speakers. So moving on to our second experts or first expert speaker for the day today, I would now like to invite Rob Sampson, Managing Director for Ceres BioSystems India Private Limited, and his talk is going to be on sustainable organic waste management. Over to you, Rob.
Thank you very much, Kailash. Good morning, good evening, depending on what part of the planet you're viewing us from today. Let me just share my presentation here. There we go. I'm hoping that's showing up on everybody's screen. I'm going to talk today. I'm going to talk today about sustainable solutions to organic waste management. And we actually have an actual industrial demonstration, well, 2 industrial demonstration, one in a municipality and the other on behalf of an industrial company that I'll speak to at the end of my presentation. So right now, organic waste management is, well, on its infancy, if you will. Traditional disposal technologies for industrial or municipal sewage treatment waste is by landfill or direct to farm land application. However, both of these have huge environmental issues, one of which is groundwater and surface water contamination that could originate. There are alternative solutions to organic waste management. In fact, organic waste should and is now worldwide being seen as a source of nutrients for farmers. I just saw a slide, not a slide, but an article recently in the Times of India that says it's time now to think of organic waste as a resource and not as waste. And in fact, that's the attitude change that needs to happen worldwide, not just in India, but worldwide, because we can no longer continue to treat organic waste, nor should we continue to treat organic waste as a waste. It's actually an organic resource. This is a picture of organic fertilizer that we are currently producing in India now, and we have been for, I guess, about 6 years with the help of folks like Ravi and his team. And it indicates how we can indeed, on a commercial basis, this is not a laboratory basis, but a commercial basis, produce a final product that has nutrient value for Indian farmers. Most jurisdictions regulate the use of industrial or municipal organic waste by regulating the final product itself. And in this particular case, the standards of regulation tend to follow what the U.S. Environmental Protection Agency has set in various categories of organic waste management. One called EQ Biosolids, which is excellent quality. That's what EQ stands for, Biosolids, which is a high quality organic waste material. Then there's Class A, sort of the next grade down, if you will. And finally, Class B, which is essentially untreated organic waste. The first two here, EQ Biosolids and Class A, are allowed by regulation to be applied to fields as a final organic nutrient to the farmer. The final category, Class B, is generally not allowed to be applied, or if it is allowed to be applied on farms, it's highly regulated and application is limited, primarily because of the pathogens that are still contained in the final product. Our final product is a full pathogen-free fertilizer, and it compares quite favorably to commercial fertilizer. You would know it as urea or MOP, either a nitrogen or a phosphorus additive to farm fields. In fact, not only is our product full of nutrients and nitrogen, phosphorus, potassium, and organic carbon, it's also pathogen free. In other words, the application of this product, even though the original raw material is organic waste containing pathogens, our product contains no pathogens and can be handled quite easily by the farmer. Interestingly enough, we have done some analysis, and some work's been done by the Canadian government on our product as it relates to its GHG impact. And it's been proven that there are up to 2 tons of GHG credit for each ton of the organic waste material that is consumed in our product. That's a credit. Other advantages to our product is it reuses organic waste along the theme of treating organic waste as a resource, not a waste. It minimizes the wastewater discharge and contamination to water sources that occurs when the raw organic waste is simply landfilled or applied to field without any treatment. And probably now, even more importantly for Indian farms and fields, it returns organic carbon to the fields and soils. There is a growing concern about the increase in organic carbon deficiency in India fields, which eventually leads to yield reduction. And that deficiency in organic carbon is actually being triggered by the overuse of commercial fertilizer. So what is in water and wastewater? What value is there? We said that we should be treating it as a resource. So what is the resource there? this is just a picture, if you will, of an average organic content of, in this particular case, municipal wastewater. So what's in the material that we distribute through our municipal wastewater system? Well, there's a large component of suspended solids, which is essentially organic carbon, a large percentage of nitrogen, and a smaller percentage of phosphorus. But when you add all that together, and this is literally just from the wastewater production, if you will, across the country of India, the nitrogen, carbon, and phosphorus components in that raw material actually equates to a considerable amount of organic fertilizer or organic nutrients that could be applied back to the fields of India in a safe way. And this is literally just from the wastewater side, not the organic component of any industrial supply. That would add to this volume. These are considerable volumes of organic fertilizer that could displace the use of inorganic fertilizer, i.e. commercial fertilizer, on a sustainable and continued basis. These are yearly volumes that show up no matter what you do. This is a picture of, or a slide representing how our product, our organic product that we currently produce in India now, compares to commercial or industrial produced fertilizer like urea or potash. Our application rate is about 1.25 tons per acre, and supplies a considerable amount of nitrogen, sulfur, phosphorus, but more importantly, organic carbon back to the fields of India. This compares the nutrient value and some heavy metal components of our product across the spectrum of, these are now just 2 sample tests. We do a sample test in our production facilities in India every week. But so this is just 2 pictures to show you. One when we started production in 2016 is December of 2020. I could easily show you December of 2021. But what I'm trying to show here is the relative consistency of the material and the qualities of the material, and how it compares to the final column, FCO, which is the fertilizer control order limit for these products. And you can see the nutrients at the top part of the slide of the chart. And as you get further down on the chart, you'll see some listing for heavy metals and how they show up. Or more importantly, how they don't show up in the concentration. We are way below the requirements of the fertilizer control order. So what does our product do? It improves crop yields. It improves the physical condition of the soil. If you are a farmer, these are 2 very important parts of soil management that you need to pay attention to in order to not only keep crop yields where they are now, but improve crop yields. Our product also reduces the potential for soil toxicity. The slightly elevated pH level of our product, it's just slightly above neutral, helps contain, if you will, some of the toxic metals that is naturally in soils now, such as aluminum and cadmium. These are our applications across various uses of our product. Agriculture is one of them. Land, farm reclamation. In Canada here, our product was used to reclaim the tailing ponds of a nickel mine in Sudbury, Ontario. It's used for landfill cover, the daily cover that's required to be and should be placed upon landfills every day in order to make sure that the landfill is properly maintained. The product can be used for general landscaping. It's been used for building and maintaining roadsides and all the greenery alongside roads. And it's also been used for wetland and shoreline development in order to maintain the greenery along the edges of those particular areas. This is a picture showing our basic production process, which is effectively a two-stage process. The first stage is a pathogen reduction process, where we mix the raw material, raw organic waste with an with an alkaline mixture, and that creates a natural exothermic reaction, which raises the pH of the mixture and the temperature, and those two stresses literally kill the pathogens. So at the end of that mixing process, the product is pathogen free. We then go through a second mixing process where we mix it with additional organic material that lowers the pathogen back to a near neutral range. And then that creates the final product, which is then bagged currently in India and shipped. In North America, we have the same production process, but we actually stop it at the first stage, the pathogen reduction stage, because soils in North America are highly acidic and they need that alkaline balance in order to improve crop yields. India's soils are not yet as acidic. They are gradually trending in that direction. So at this point in time, we go through the second mixing stage to bring the product back to a near neutral pH range. Feedstock material. Biosolids are what you would normally call sludge or sewage treatment plant waste, food waste, animal waste, agriculture waste, commercial and industrial organic byproducts. Anything that is an organic material can be used in our process. Our other additive is anything that has a slight alkalinity to it. In India, we use fly ash. In North America, we use cement kiln dust. Both, by the way, industrial waste products. There's a picture of our production facility in India. The picture to the left is our first mixing stage, excuse me, mixer. This picture on the right is a little bit more of a close-up of that process. The picture on the left here is the first staged mix process, so the pathogen-free high pH level product. And the picture on the right is the final product that's coming out after it's been mixed yet again with an organic material that lowers the pH back to a near neutral range. Again, some more pictures of our plant. That's the silo on the left, where the fly ash is maintained and stored. Picture on the right is some of our product going off to some happy farmers. Again, in India, it's bagged. In North America, it's sold as bulk material. Those are 50 kg bags sold as a fertilizer control order, city compost organic fertilizer. Those bags would be selling for about 175 to 200 rupees a bag. And we do some test growing at our own plant. The bottom picture on the right is a picture of our pilot farm, if you will, small little farm that we run at our plant to demonstrate to those who come to see our plant the quality of the final product and how it does generate and produce some good crop yields. So we do have one existing plant that we have in Vadodara. It's been there since 2016. It currently processes municipal organic waste from its wastewater treatment plant and from its municipal solid waste stream. But we do have one industrial plant that we are now building in Mumbai. This particular customer we're building a plant for, excuse me, uses Mumbai sludge, dewaters the sludge and uses the water for its cooling process. Well, when it dewaters the sludge or the sewage, it produces sludge or what we call biosolids. And so our plant will be used to take that waste, organic waste that's generated from the dewatering process and produce a fertilizer. So the sewage treatment plant waste volume, we'll see about 3,000 metric tons a year at 80% solids coming in. We're also processing some effluent treatment plant product as well at the same time. It has a slight organic content to it as well. So we'll be mixing that with the sewage treatment plant waste. That's about 1,500 tons a year. And then we're also taking some municipal solid waste, municipal organic waste that's produced by the city of Mumbai, about 2,800 tons. That's only a small portion of what Mumbai would produce, obviously. Other industrial waste that we're managing is about 2,000 tons of fly ash a year coming from a local power plant. So here's some estimates of the final product produced, about 9,300 tons a year in city compost. Initial capital costs of about 3.8 crore, and our operating costs of about 1,900 rupees a final product ton. Remember, I was telling you we sell it for the equivalent of about, well, 2,800 rupees a ton. So there's reasonable margin to be made in this business if you can do it right. That's me. That's how you contact me. We do have a production plant in Baroda in Gujarat. You're more than welcome to come and see it. Just let me know and I can set up a plant tour for you. This is a real live business. We've been in India since 2016. Our plant in Baroda can produce up to 100,000 tons of product a year. We're not doing that now yet, but that's our production volume. So you can see we can have plants small like the one we just demonstrated or the one in Baroda. And thank you very much for your time this morning.
Thanks, Rob. Thanks for sharing this presentation. We do have a few questions that I will be taking up. So we have Mohammed Zamir, who is asking a question as to what all can be produced from organic waste.
Sorry, what was the question again? I'm sorry.
He says, what all can be produced from organic waste?
Well, our particular technology produces organic fertilizer from organic waste. To me, that's the best thing you can use organic waste for. Organic waste has two values. One, its nutrient component, and two, its energy component. There are production facilities that take organic waste and try to produce an energy value out of it, but in the end, you'll end up with still waste. A biodigester will still produce bio waste. What are you going to do with that? So our solution solves everything, if you will. The energy and the nutrients go back to the field, which is where they were when they were originally generated in the form of plant and food that we eat. So to answer your question is you can produce energy or fertilizer, i.e. the nutrients, or both. And we say do both using our technology.
Okay. Mohammed is sent a follow-up question. He says, how do we degrade the organic waste?
How do we grade it?
Degrade.
I'm not sure I understand what the question is then. How do we?
Maybe I'll ask Mohammed to rephrase the question, or maybe I'll move on to the next question. The question is, what is the best way to collect organic waste?
Well, that's a very good question. The best way to collect organic waste is at source, separate at source. That's a challenge to do even in countries like North America, who have been trying to do that for years. There is a technology that we do deploy that helps us separate the organic waste from the mixed waste at receiving at the plant site, but it's not perfect. Again, the best way to collect organic waste is to separate it and collect it at source. So In North America, go outside of my house, you'll see a green bin. That's where I put my food waste. I don't throw my food waste in with the general garbage. I'm not supposed to anyhow. Um, and because we do that, then the food waste that gets collected is far cleaner. As far as municipal solid waste and municipal sewage treatment waste, the best way to collect it is exactly the way we're doing it now in all countries, which is through a sewage system.
We have a question from Subhashish Pal. He's asking, how do you collect this industrial waste or this bio waste? To elaborate a bit about the supply chain?
Well, so let me answer the question for the two plants that we have. One in Gujarat, the organic waste from the sewage treatment plant is collected at the sewage treatment plant by us. We manually go in and collect it from their settling ponds. The food waste we use in Baroda comes to us in a number of different forms. We receive it from composters, but we also receive it directly from commercial and industrial producers of it. So they ship it directly to us, separated again at source. We don't take anything in our Baroda plant now that is not separated in some form. The plant in Mumbai will again deploy the same technology. We will take the organic waste from their sewage treatment plant separated. The food waste will come in a separated but raw form to us. And so we're trying to encourage the suppliers and the producers of the waste to deal with the separation at source as much as possible, which is the right and correct way to do it. Yes, it's a little bit more complicated. Yes, it's a little bit more expensive. Yes, it requires a change in attitude by the producers, but those are all good things to encourage.
So Rob, we have a question from Manas and Karthik. They are both asking, can you let us know if there are any carbon credits for treating organic waste?
Yes, there are. If you have, so you've got to go through a rather complicated process, and we've not done that yet in India, and we did not do that in Canada. We have not done that yet in Canada. There's a very complicated process to get your carbon credits valued. Sometimes it's more expensive to do that than to actually get the value of the carbon credits. It turns out you pay the consultants and the lawyers more than the value of the credits that are generated. So there is a process to do that. Again, it's complicated. You have to find the markets to sell the credits into, and those are not as strong and robust as people say they are to get the actual dollars in your pocket. But if we were to do that, there's a significant value to the credits that could be generated. You have to have also a large volume of credits to sell before you can frankly afford to pay the consultants and the lawyers the money that are necessary to get to the point that you actually have a credit certificate to sell.
So we have a question from Shrirang Bhalerao. He's asking that typically a dewatered biosludge from a filter press or centrifuge may have 25 to 35% solids and the rest is moisture. He's asking, can this be used directly as a feed or does it need to undergo further dewatering?
Yeah, it needs to undergo further dewatering. And so fortunately in India, the dewatering can be done quite quickly and naturally by using sludge dewatering ponds, which to a large degree would negate the need to use the mechanical system to dewater it. So in North America, we don't have that luxury. So if I'd show you a picture outside my house right now, you'd see 3 or 4 feet of snow. So it's a little difficult to dewater sludge naturally in that environment. So in Canada, we do take mechanically dewatered sludge, and we still mix it with the material that we've go through the same process, but at the back end of the process is a dryer, literally a gas powered dryer that dries the product up to about 80 to 90% solids. That's hugely expensive, and not needed in your country where you have a natural ability to dry the product in the drying pond. So the answer to the question is yes, it would have to be dewatered up to about 50% solids.
We have Afsar Ansari asking, what about fecal coliform and other bacteria in the waste?
Same thing. So all of the bacteria, the first stage of our mixing process, the pathogen reduction process, neutralizes all of that bacteria. We have never, ever had a pathogen test in any of the products in any of the countries we've produced since we started this process back in 1980. Never. And we test for pathogen weekly. That's the key advantages, if you will, of our technology. And it's literally the pH rise and the temperature rise that neutralizes and kills the pathogen, including fecal coliform.
We have Arsh Anwar who is asking the question, what type of waste are you collecting from the wastewater treatment plants?
We're collecting currently in Baroda, we're collecting sewage sludge, and it comes to us from their drying beds, and we recover it from their drying beds when it's about 50% or so solids.
Okay. Just, I mean, a request to all the other speakers that I'm taking these questions because, you know, it would make sense to have them answered while it is fresh in attendees' mind. So please bear with me for a few more minutes till I take these questions. So Rob, Hiten, and again, Brian are asking this question, how the active component from pharma or other chemical industries are destroyed to ensure that the same is not having any adverse effect? Or how do you manage possible heavy metal contamination?
Right. So heavy metals don't disappear. This is not this technology is, there's no magic wand to wave and poof, the heavy metal disappears. They have to either be not in the material or in the material in the acceptable levels, or they have to be extracted from the material. Our process takes in the product, the raw material, in concentrations that are acceptable and allowed under the various regulations and rules that we have. We heavily police that. So when I say we do our weekly testing, we not only test the final product, but we test the raw material to make sure that it doesn't have a heavy metal content that's going to create some problems for us in the form of the concentration for the final product. Let's be clear. If you were to go and grab a sample of dirt outside your house now and test it, you will see the full array of heavy metals. Heavy metals is in all of our soils in various concentrations, depending on what country we are in and where that soil is retrieved from. What the magic is to not to add any more than that current ratio is, if you will, in the soil. And that's what our final product is designed to do. We are not adding to the heavy metal concentration in any of with our product. Having said that, the higher pH level tends to demobilize the movement of some of the heavy metals through the plant structure. And so the advantage to our higher pH level product that we produce in North America is it has a higher ability to demobilize any of the heavy metals in the soils and keep it concentrated in the soils and disallow it, if you will, from moving into the root structure and the plant itself, which is what we should all be trying to achieve. But so I'm hoping that answers the question. The product is regulated on heavy metals by your current fertilizer control order standards in North America, by other standards, and we stay well below that by encouraging a raw material supply that doesn't have that contaminated level in it.
Ami Shah is asking two questions basically. How do you manage the heat release during the first phase? And the second question is, do you add nutrients as additives in phase 2? If yes, in what form?
I'll answer the second question first. Sometimes we add more organic matter in the second mixing stage to make sure that our final product has a high organic carbon content to it. So it depends again on the raw material supply and what quality of organic carbon is in that. That tends to be the only organic additive that we would sometimes, but rarely use. And that's because we capture the raw material before it degrades a lot. Any organic material will start a process of decomposing and degrading. Degrading for organic materials, another word for that is called composting. Composting consumes carbon. So if you grab the organic material when it's fresh, it has a higher organic content to it. So the first question was, how do we control the heat, I think? Yeah.
Yes.
The heat is actually used to kill the pathogens. It's part of one of the two critical components that kills the pathogen. Over a period of time, the heat dissipates. So if we didn't go through our second mixing process, the heat would naturally dissipate over a period of time, i.e. the pH would fall slightly and the temperature of the product would just naturally return to ambient temperatures. And that's what we do in North America. Actually, in some components in North America, we add more heat because we want to dry the product up. But in India, when we go through the second mixing process, the heat naturally dissipates. And so the final product that's bagged is an ambient temperature product.
So I'll take two more questions, Rob. One is from Jian. He says, do you collect primary sludge, secondary sludge, return activated sludge, or all of them?
We would prefer primary. Again, you got to realize what we're trying to produce is a product that has a high organic carbon content to it. So the more organic matter in our product, the better final product we can produce. The more you go through the treatment processes of a wastewater treatment plant from primary, secondary, into tertiary treatment, the more the organic carbon is removed and actually gets dissipated. You'll see that in the odors that would be around some of the plants. The smelly odors is actually carbon being removed and converted into odor. So our preference is young, fresh, organic waste material. That doesn't mean we can't take it as it's gone through the various treatment processes. It just means that what we'll see is less and less and less of an organic carbon content. And that's what farmers are actually looking for. Yes, they like the nitrogen. Yes, they like the phosphorus, but boy, do they really need the organic carbon content. And so we try to deliver a product that has the highest maximum amount of organic carbon as possible.
A question from Mohammad Zamir is, what happens when organic waste ends up in a landfill?
It decomposes. One and two, to the extent it's not treated, the pathogens go somewhere. We've had a very bad experience here in Ontario, and I think Ravi can probably fill you in if you want any more detail, where a freshwater collection system was contaminated by organic matter that it was decomposing, basically dumped in the vicinity of the collection side of that water system. So the organic matter will decompose naturally. That's what organic matter does. Methane gas will be produced because that's what you get when organic matter decomposes. But more importantly, the pathogens will leach somewhere. And if you have a fresh water source in the area, that's where it'll go. And that's where you don't want it to go.
So Rob, one final question. Arun Kumar Agarwal is asking, what is the power/energy production per ton of organic waste generated in a typical STP?
What's the power production?
So basically, if I think the end product, instead of a byproduct like a fertilizer, if it is energy, so what is typically the production per ton of organic waste?
Well, it depends on the technology you use. Biodigestion is one way in which you can produce power. So basically, you put the organic waste in a vessel, it decomposes, produces a flammable gas. The gas is then burnt and produces power. I'm not an expert in that. I don't believe the power production value is very high for that. And it depends again on the quality of the organic waste, because that's what contains the energy. How much of the energy of that organic waste has been lost prior to you turning it into energy? We have done some experimentation. So we experimented about 8 years ago with producing a fuel pellet from organic waste. And we were able to do that, a fuel pellet that was burned in a very simple combustion process. What we found is we would be able to extract net about a quarter to a third of the energy value of the original raw material. And we were using at that point in time very fresh sewage sludge. So not very high recovery.
So thanks, Rob, for this wonderful presentation and patiently answering all the questions. I would request you to maybe stay on in case we have some more questions that come into the Q&A box. So thank you once more, and I'll move on to the next presenter, please.
Thank you very much, Kailash. Thank you.
So moving on to our next expert speaker for the day, I would now like to invite Ms. Meni Mancini. She is the founding partner for TradeWorks Environmental in Canada, and her topic is going to be on empowering nature for a sustainable future, how to save time, money, and the planet through biological optimization. Over to you, Meni.
Thank you so much. Really appreciate the opportunity to be here. Good morning to those of you who are joining from Canada like I am, and good afternoon, good evening to all the rest of you. Really happy to be here and share a little bit about what we do and how we're enabling and empowering nature to really create some wonderful things. So you can see my slide. I'm queued up.
Yes, we can see your slide.
Excellent. Thank you so much. So just a little introduction in terms of who we are. We are headquartered in Ontario. We are very proud of the fact that we are a woman-owned, woman-led firm. And even though our head office is focused in Ontario, we have projects around the world that are supported by a growing network of agents and distributors. And what we do is we offer sustainable solutions for hard-to-treat organic waste and wastewater. And a little bit about what we do is similar to what Rob mentioned, focusing on nature and how do we extract the most value out of nature. We as well utilize the natural ingredients of microorganisms that are used to really boost and perform treatment systems. And how we do it is through tailored analytics. And I'll get more into that. But really what I want to share is the why. What has us get up every day, get up early to really do what we do? And it's because we have a passion to really make a difference. We really take seriously the responsibility that we have to be good stewards of the planet. And we have a unique opportunity like we do here on this forum to really collaborate and educate so that we can really drive more sustainable practices for the organic waste and wastewater treatment industry. And really, there's no time like the present. It's, you know, when we take a look at our world today, it's important for us to really become aware of the impact that we're having around the world with our practices. And the pace of growth and the pace of industrialization is outpacing the pace of innovation. And just a few little stats that really put into perspective the pace of growth. Over 2 billion tons of organic waste is produced annually, and that's increasingly growing. And scarce water resources are being maxed, and the global industry for industrial wastewater treatment is valued at over 10.9 billion. Industries and municipalities face challenges and pressures to do more with less. And that pressure really results in a lot of challenges that a lot of these utilities have to deal with: increasing growing population, aging infrastructure, inefficient practices, budget constraints, environmental regulation, and increasing number of events. All of these pressures, a combination of these pressures, these industries need to deal with. And therefore, it's important now more than ever before to find innovative solutions to improve efficiency and performance of treatment without adding additional footprint. Today's practices aren't sustainable and cannot keep pace with the increasing demand for water and for land. Radical change needs to happen. And we feel that at TradeWorks, through our solution offerings, where we combine biology, equipment, analytics, and know-how to address some of these wastewater challenges, we're well positioned to help existing systems to optimize their processes. And that's really what our focus is the focus of optimizing biological treatment process. So we offer 4 solutions essentially to support facilities. The first is we focus on prevention by using our microbial formulations. We have a suite of 25 formulations that are designed to really optimize the existing treatment processes while they offset some of the negative byproducts. And I'll share a little bit about that. And not only does this drive performance benefits, but it saves money. And supporting the use of our microbes, which are applied at different stages and for different performance targets, we have the hydro process. The word hydro is an ancient Greek word that stands for water and the sacredness of water. And we have it represent the importance of the stewardship we need to have in this precious resource. And so the hydro process combines these formulations with analytical capabilities to really systematically target improvements and optimization. And we synthesize complex data to really help make important and powerful decisions on improving the process. And we also have a piece of equipment, which is our biophysically enhanced prime screening, which is designed to provide water as clean as a primary clarifier without the need for that step for wastewater treatment, which means that countries that discharge untreated wastewater into the environment without being treated would really benefit from this technology because we're able to provide significant degradation. And I'll share a little bit about how we achieve that. And of course, underpinning all of our efforts is our technical know-how, because it's in order, and we really support and advocate for water recycle and water reuse and support the design of these types of systems because how the importance of our water resource. So with our technology and primarily focused with our microbial additives, we are able to support the circular economy, and we benefit many users around the world. So to get this picture here, this slide really indicates the different types of applications that we have where we utilize our microbial formulations. So for example, we apply our microbial formulations in collection systems around the world in order to reduce H2S, break down fat, soil, grease, and sludge, deal with sludge. Our prime screen is used to boost and enhance performance. We can optimize biological nutrient removal in plant, as well as we work with different lagoons, such as sludge lagoons in remote communities like Hawaii, where we're optimizing these lagoon systems. We're bringing them back into compliance. We're helping facilities achieve compliance through the use of our microbial additions. And we also support waste to energy, enhancing anaerobic digestion if that's the path the organic waste is taking, as well as we can improve the efficiency of compost by creating better quality compost and reducing the odor and so much more. So essentially, I want to share a little bit about how our microbes and what's so unique, because in all these biological systems, they operate through the use of the microbes that are found inherently in these systems, but they have a lot of byproducts such as odors. The difference with the addition of our microbes into the various systems, again, according to the targets, is that our microbes are designed to boost and enhance the microbial activities. So they can, if the target is to degrade, then they will enhance the degradation. If the target is to improve the nutrient quality, they will do that, because we have a suite of formulations that achieve that. But key is that our microbes take different metabolic pathways. And because they take different metabolic pathways to degrade waste, they have more efficiency from an energy consumption perspective. And we can deliver significant benefits by not releasing the H2S, by disengaging the mechanism of what creates the H2S. And so this diagram that I'm showing up at the top right-hand corner shows the typical nitrogen cycle that for conventional nitrification, denitrification. I won't get too detailed into this, but essentially with the use of our microbes, we skip the most energy consuming stage to get to the more accelerated nitrification, denitrification process. But what's key is that we are not a one size fits all, and we work according to what the targets are. And we really focus on site-specific challenges and how to manage those site-specific challenges, typically looking at what is the existing footprint, what is the existing process, and then what are the target objectives that need to be achieved, and then how do we support and close the gap, utilizing the right product, the addition of where that product would be added, as well as any process modifications if needed. But just to give you an example in how we work in different industry applications, is that regardless of where the industry is discharging, for example, if it's discharging into a recipient, a body of water that has much more stricter requirements in their permits and the types of parameters they need to meet, we can support them in that. Or if they are discharging into a municipal sewer grid, and so they would require some pretreatment. The overall essence of what we can do is we can substantially save a facility, their operation and maintenance cost, make the wastewater management process more efficient, more effective. We can also work to help them earn and monetize carbon credits. I'll talk a little bit about that. But typically the biggest difference with our addition of our products, our equipment, and our process is that the alternative is to build bigger. In order to in order to enhance treatment capability, you require a larger footprint. And so with utilizing the same footprint, we can produce a higher quality effluent product and process. And the bottom line is that using our technologies, we're able to turn bodies of water that look like the picture on my left, which is a lake that is the recipient of effluent from municipal and industrial wastewater system. And even though they meet the permit effluent, it still wasn't the ambient environment for this ecosystem. And so we're very proud of the work that we do, where we're helping communities develop clean and thriving ecosystems like the photo on the right. And so what I'd like to do is, there's lots of opportunity for us to really expand our footprint in many countries that really need to preserve and protect their precious ecosystem. And for the next part of my discussion, I'm going to focus on some of our innovative applications. I want to talk about the methodology as an example of how we approach the thought process of how we apply our methodology. Not that it directly overlays in any industrial application, but it gives the idea in terms of how our process could work. So the most beneficial and innovative preventative approach to the application of our Hydro Series product is within the collection system or the sewer system. By dosing the product in manholes, lift station, in collection systems where there is a collection system, we're able to precondition the water before it enters the treatment plant. So in addition to the odor and FOG reductions, the influent quality is significantly improved, resulting in more downstream benefits. And we can also support industrial contributors that are discharging into the collection system or into the sewer system to deal with various biological process issues, leveraging that preconditioning component of the water before it enters into the treatment plant. Conventionally, the collection system is only used for conveyance, to convey the water to the treatment plant, and treatment happens at the plant. And then when there is additional loads that take place, there's burdens on the plant, and to enhance the treatment capacity, expansions are typically required. By leveraging the journey of the conveyance, we're able, as I mentioned, to not liquefy, but break down fat soil grease. And so the influent quality can be significantly improved. This is one example of how we're helping communities really deal with that gap fill where they're growing, they're expanding, and they're not quite there yet in terms of the financial or the space to build a larger treatment plant. And at the same time, we're able to deal with supporting some of those industrial contributors. Industries are essential to the economic development within a community, within a municipality, but often the additional variability in production, for example, really affects the municipality's wastewater treatment plant. And we're a tool or resource that can be used to really support and balance not only cleaning the grid and creating good sewer grid health, but also within the treatment plant. And so I'm going to share two use cases. One is where we are applying our microbes in the collection system, and we have our very fine screen technology for a municipal treatment plant. This plant is located actually in the United States, and the objective of this application was to really support the municipality with eliminating odors. They had frequent odor complaints, and they also had industrial contributors that were producing sauce manufacturers, high fat soil grease. And so there was significant clogging within their collection system. And they were also challenged with the regulators forcing an enforcement act to be able to deal that, because odor is not only a nuisance, it's also hazardous to health. And we also introduced our fine screen technology in order to deal with all the junk that people would normally throw into their toilets or that collect through the collection system that would create burden in the treatment process. So this is just an indication of a lift station, which is an example of urban sprawl and how municipalities are faced with communities expanding, industry expanding. So now they're bumping up against infrastructure. And notice how close, and this is the lift station that was clogging significantly close to home, and there's industry further up. And after the first month of applying our microbes in the collection system in targeted locations, we were able to minimize the H2S, and there was no odor complaints where previously they had odor complaints to the federal agency that was involved. The application of our microbes also, prior to our application, there was CCTV to establish effective baselines. So prior to the addition of our microbes, the system, the sewer line was over 70% clogged with fat soil grease. And after 3 months where they retested the CCTV to do a comparative, it's always important to have baselines and then have comparative to demonstrate the effectiveness of an application. We were able to demonstrate how we effectively degraded the FOG, that they could even read the label within the piping system. And more importantly, they were able to reduce the frequent maintenance that needed to take place on these lines. And this was especially important during COVID, where the more safety we can provide for operations staff, where they're not coming into contact with sewage or that process was important. And so whereas prior to our application, the H2S within the areas in a facility that typically would be stinky, for example, this is the H2S reading in the lift station, the middle is in the headworks, and this picture on my right is inside our screen. Normally they would have significant H2S creating alarms, and the operations staff would have to have their meters for safety. We were able to reduce the H2S to 0 because our microbes are designed to focus on prevention and to disengage that mechanism of what creates H2S. The images on this slide illustrate the prime screen. It has a unique design, and the solution offers multiple operational benefits. It's in comparison to primary clarifier. So if there isn't one, there's no need to have one. And there's many additional benefits that the synergistic effect of our microbes working in the collection system or in targeted locations along with the equipment ensures that there's no clogging. This particular facility is an MBR facility, membrane bioreactor facility, and actually one of our key inventors of this technology is also a noteworthy inventor of MBR for another Canadian company that was one of the first to pioneer MBR technology. And so this screen has been in operation for over 3 years now in the facility, and it is so clean because the microbes break down the fat cell grease and don't allow the clogging. And so we're able to have very, very fine screening technology that screens out the junk and provides significant additional operational benefits. And you can see here zoomed in is an example of the screenings that are collected. This would normally enter the treatment plant. Now, this is an example of a municipal plant. However, the screen can also be applied in industry. We commission and adapt according to what the targets are and what the process, the wastewater treatment process is. And we have automatic compacting, an automatic compactor that will bag the screenings. So there's no need to come in touch with the screenings at all. But more importantly, when we look at the parameters and the key parameters and what the average influent parameters were prior to the addition of our prime screen, which is the fine screen along with the microbial activity, we are able to provide significant reductions in BOD as well as TSS, phosphorus, nitrogen. Normally, you would need to add an expansion and an additional treatment process in order to achieve results like this. And so in summary, this application, we were able to eliminate the odors, fat cell grease, really support the community and not having the enforcement acts that they were subject to have. We were able to reduce their operations and maintenance costs by 35%. We saved them a $5 million expansion. And now our process has become part of the standard operations for over 3 years. And we're able to support the industry with its variability in treatment process. And that's why I wanted to really introduce the municipal application, because often they do tie in and industry will impact the application within a municipality. Moving on to another application. This is an industrial application in Thailand where our target objective, this project is an industrial wastewater treatment plant that is treating wastewater from an industrial estate area, specifically for natural rubber processing. The objective of this project was to determine the efficacy of the biotechnology with introduction into this type of application. And the objective is really to improve the effluent values of the wastewater treatment plant so that the discharge is improved. As you saw in the picture of the lake, we want to really work to improve the qualities and be better than we can so that the recipients also have the benefit of improved quality. We wanted to work with this facility to control and minimize their shock loading effect based on the variability in production, based on their cleaning procedures that would have an impact, and also to enhance the overall performance and efficiency. The challenge as well, especially during COVID, was huge staff shortages. Thailand was hit very hard with COVID. And so if we can help save on staff usage by improving the overall biological process, that was important to them, as well as to minimize energy consumption and really focus on minimizing odors and FOG. Now, one thing I wanted to note, this is a sequence batch reactor type of a treatment plant. We are agnostic to the type of treatment plant or activated sludge method the facility is using. We integrate in and can adapt our process. We are an input into any system. It's just important for us to understand not only the layout, but how the operational process works. And with our applications, we work on monitoring, measuring, analyzing, and reporting. So the results that we produce really follow a scientific method. And the more information that is provided from a baseline, then the better we can show the performance results through a data-driven approach. And if the baselines and the proper parameters aren't being monitored, we ensure that there is a stage for ensuring proper baselines are established. The better we can monitor and measure something, the more effective the results and the demonstration of the results can be, and then they can be quantified. And so we were very successful with this application. We received letters of recommendation, and we're working closely with the trade commissioners in that region so that we can expand our efforts in that market. And ultimately, the results that we were able to produce is improve significantly their effluent values. So, and improved the criteria overall. The shock loads were minimized. The secondary treatment stages were not required because of that because our microbes are efficient and take different metabolic pathways. We were able to minimize the need for a secondary processing, and aeration stage demand requirements of energy were reduced. And our sweet spot is odors and minimizing and targeting odors, and we were able to accomplish that. So this is just a really quick snapshot of 2 case studies that we have. The commonality of our efforts and the benefits of our solution is really offsetting the negative byproducts, such as reducing H2S, reducing fatso grease, revitalizing aging infrastructure is something we're also doing in countries like Singapore and in Canada and in different parts of the States to increase capacity. We can reduce the organic load to treatment facilities. If the target is to decrease excess sludge, we can degrade it on site. So even though there is a value for sludge, whether it's waste to energy or waste to reuse, often the cost of those types of processing can be expensive from transportation and additional processing. And where the target is for us to work on decreasing the sludge on site, that is something we have formulations to achieve that. We can assist in minimizing expensive upgrades, improve energy efficiency, and we also work to calculate and monetize carbon credits. And as our previous speaker, Rob, mentioned, it is a complex process, but it definitely can provide some significant financial advantage to offset some capital costs for different applications. So in closing, I just want to share a little bit of our unique differentiators. Our solutions are tailored for site conditions. We integrate into existing systems. We take an analytics-based approach. We're cost-effective to alternative, enhance, increase footprint. And we have an expert team that adds an extension and can share and expand knowledge, which is essentially what we need to do, collaborate to advance the industry, advance knowledge. And really through our solutions, by using nature and empowering nature and providing the support to the biological community, we're able to save time, save money, save the planet, be sustainable, provide social, economic, environmental benefits, and really demonstrate how we're moving the global needle forward in sustainability. And we work with our clients that are interested in establishing the right metrics on how our technology is really moving these numbers forward in sustainable development goals. And our process is integrated, so we work at identifying targets. We provide a design experiment, if you will, a scope of work. Acclimatization is quick, especially with the use of our microbes. It's easy onboarding, low risk to demonstrate the effectiveness of microbial addition and empowering nature. And if you'd like to get in touch with me and to learn more about how we can work together to empower nature, because each one of us holds a responsibility for future generations, we are happy to do so and align with those of you who are interested in sustainable practices. Thank you so much.
Thank you, Meni. We do have a few questions for you, which I will take up now. So we have Manish Ojha, who is asking a question saying, can you suggest or compare the performance of SBR versus extended aeration in terms of nitrification, denitrification, BOD removal, or COD removal?
So with our technology, we are agnostic to whatever the process is. So we don't adapt or change a system. If a system is an extended aeration or an SBR, we will integrate and work on achieving the performance targets that that facility is looking to achieve. So from our perspective, we're agnostic to the process, but we will work to whatever the targets are. So if an extended aeration plant is looking to reduce their energy demand, we can integrate the right microbial formulation that we would operate under conditions with reduced DO, dissolved oxygen, so that we can support that process. Again, every facility is unique, as is the way they're operated. And the key to what we do is to look at what are the targets they're trying to achieve, and then how are they operating? What is the environmental condition and the operational condition? And then that delta is what we close the gap on through the right product, the right stage of addition, and as well the right process adaptation if needed.
Okay, we have one more question which says, can you suggest as to up to what extent can dissolved COD be removed in biological processes?
To what extent we can remove BOD in or COD in biological processes? Yes. Again, it depends on what the target is. Sometimes the target is they want to maintain their BOD depending on what the downstream process is. So we don't create a unilateral target, but we have gone as far as reducing the excess sludge haulage from certain plants, if that is the target. So where at the end of the process, at the end of their biosolids process, the digester stage, where they would normally haul away or further process, we can significantly reduce that. We've also worked in facilities where the influent loading was very high. It was very high either to a redistribution based on COVID, people being home, that created some challenges for municipalities, and we were able to provide solutions for that. Again, it all depends on the target, but we can go pretty far, and it looks at it. It depends on what the objectives are, what the existing process is. We integrate into systems, so that presupposes that they have a process already, and then we go from there.
Okay. Ami Shah is asking this question: what is the continuous flow that can be handled, and what is the typical contact time required for the biological screen to work?
Again, it all depends on the what we're treating. It all depends on the type of process that is in place, because the screen is designed according to what the design criteria is of a facility, according to what they're targeting. Ideally, we try to ensure the more retention time we have, the more optimized opportunity we have for the microbes to work. That thought process works essentially in the collection system in municipalities, where the longer the lines, if there's problems in certain areas, I know I'm answering on both sides, but the further we can go from the source point of the problem, the better, and then the better benefits we have for the facility as well. So again, it's all site specific, but we have an engineering team, a science team that works with the utility or facility to be able to demonstrate the best design criteria and the best integration.
Okay, we have Manish who is asking a question. Can you suggest temperature range for nitrification and denitrification?
Again, very site-specific questions. I'm not the PhD technical expert, but again, we adapt into the environment according to whatever the conditions are. The difference with our technology application is that we take a shortened pathway because our microbes operate similar to the Animox microbes without being Animox and without being in granular form. They take a different metabolic pathway, and so they create more efficiency according to what the environmental conditions are that we're implying them, determines what quantity, what process adaptation, any modifications that need to take place within the process. We're not a one size fits all, which we use as a unique differentiator for us to address specific site condition challenges. And we provide the right operational protocol and the right operational parameters according to each facility requirements.
We have Sajid Shankar who is asking, is the same microbe used for FOG and H2S removal, or are they two different types of microbes? And are these microbes pH dependent?
They are not pH dependent. We have a wide range of formulations that can be used in different industries. And the formulation for H2S and FOG, we have, if that is the target, we will provide that one formulation so that they're not having to use multiple formulations in an application. And that's really a key variance or a key difference in terms of what we do. Once we understand the full scope of what the target is, once we understand the full scope of the process flow and the operational flow, we don't have the operations team have a number of formulations that they have to manage and handle. We ultimately look to see how can we do have 25 set formulations, but we can also curate specific formulations for a target if that is what the facility is facing something different. Typically with our microbe addition, we don't need to add additional additives. We don't need enzymes. We don't need pH stabilizers or anything. It's all encompassed within our formulation. They're natural occurring, non-toxic, just a little bit more, the non-toxic, non-GMO, non-animal derived, and we have successfully imported our microbes in different countries around the world. So we've gone through the import regulatory process to do that.
Okay, we have Afsar Ansari asking whether the nitrifying bacteria are available in liquid, powder, and how much time is required to make them effective in tanks?
That's a good question. So our product is super concentrated and it's in powder form so that it provides not only reduction in cost from a transportation perspective, we're not shipping water. Also, they are, it preserves shelf life. So they're freeze dried on a brand carrier as an example, like a natural carrier, and they are activated before usage. Ideal time of activation is anywhere between 8 to 16 hours. So that wiggle room allows us to ensure that we can integrate into the operations team schedule. So dosing would take place, for example, or activation would take place the night before, dosing the next morning. All that parameter is evaluated based on the operations team schedule and where and how the addition is added. We provide all the protocols, calendars of activities and events according to what their process is, so that we can have it be as seamless and easy to add as possible to their operation.
So Senthil is asking this question: do you assess the plant by visiting it, or do we share the design? And two, is your solution adding bioculture to the system? What is the smaller size you can work?
So COVID has really helped all of us adapt and pivot. And so we actually have performed remote tours, site tours. So typically what we do is we need the operational data, we need the drawings as well. We have conversations, discussions, but actually the Thailand project that I showcased was completed during COVID without a site visit. Site visits are always ideal, but often not feasible. And we don't need a site visit in order for us to provide a cost benefit use case application. We can actually support remotely. And often we look for strategic partners that are locally based, but we are always available to support the facility, and we don't need a site visit.
Okay, Arun Kumar is asking a question. Is there any treatment required for the screen refuse so that it is disposed hygienically?
If there's any treatment for the screen, no, there is no treatment required. The synergistic effect of the bugs working to break down all the FOG, you saw how clean the screenings were. We have the option of automatically bagging, compressing and bagging the screenings, and they can be sent directly to landfill without needing to come into contact with human touch.
So what is the typical shelf life of the product is a question.
The typical shelf life for the product is 6 to 8 months. That's the ideal. I mean, we say a year, but we typically like to send fresh product. So within every 6 to 8 months, that is the longest we advocate having it.
Okay, Montu Lakhani is asking, do you have any installation in India, and do you do any soil remediation project?
We are early stage in India. We are working with a large nutraceutical company, and we're in early stage. We've signed our NDAs and we're working in discussions, and we've provided proposals for a large anaerobic digestion. So we don't have a footprint. It's a market that we're interested in. We're here at this forum because we're really looking to expand. We know the need is great for what we can do in India. So we're really interested in expanding our footprint there. So that's the first part of the question. What was the second part of the question? I didn't catch it.
Do you do any, yeah, sorry.
So the first part of the question is, do we have a footprint in India? And we're early stage. We're just engaging with 2 large companies in India. So we haven't landed in India yet, but we're interested in that market. And what was the second part to that question?
Yeah, let me just, check it out. Do you do any soil remediation?
Oh, soil remediation. Okay, so we do have formulations for that. One way that we do support organic waste systems is by accelerating the degradation process. So whatever timeline normally it takes to produce, say, composting, we can accelerate that through the use of our microbes, and we increase the quality of that compost. So we create living soil. That's one way that we can support in the remediation. And we also have microbial formulation, a microbial product that can enhance the soil conditions as well. But the main focus of our applications is really focusing on the wastewater and organic waste, and whatever path that takes, we can support those applications. We also work in aquaculture. So if there's a great need for a certain product application, we have the ability to develop a formulation with the different strains. We're actually we are actually adding microbes in collection systems in cold weather climates, like in Halifax, part of our team is out in Halifax, where they have cold, extreme weather conditions, where typically microbial activity would be inhibited, and yet we have some chlorophyllic bacteria that the performance is not compromised due to temperature.
Okay, I'll take one final question, Meni. Our next speaker is waiting. So the question is, can your technology be used for lake water treatment, which has not been treated for years?
Yes, and that the case study that I showed, where I show a picture of a lake, that was a lake that was actually the community invested a lot of money for economic development, and it was a dead, stinky lake. Nobody wants to go to restaurants or walk the boardwalk, no matter how beautiful it is, when you have dead fish floating. So our approach to how we remediated that lake and how we remediate lakes is to first look at what are the recipients, like what are the treatment plants that are discharging. So we take a two-prong approach, not looking at both the contributors into that system and how we can optimize them. And then we also can do in-lake applications. And that's what we did with that application that I showed the illustration on in my slide. That's the end game, to clean our water.
Okay, thanks, Meni. Thanks for taking time out of your schedule and coming early morning from Canada to address this forum. So thank you very much. Before I move on to the next speaker, thank you.
Thank you. Thank you so much. It's my pleasure and really passion to really make a difference. So thank you for giving us this opportunity to share. Take care.
Thank you. Moving on to our final technical presentation for today, I would now like to invite Jatin Mehndiratta. He is the Head Business Development and Channel Partnerships for Pani Energy in India. And his presentation is still going to be on IoT and AI-powered optimization for wastewater treatment plants. Over to you, Jatin.
Thank you, Kailash. I hope my screen is visible. Am I audible?
Yes, you are.
Okay, great. Good morning, good afternoon, and good evening for all of you. Thanks for taking out the time. So Pani Energy, we are actually bringing forward a decision support or a decision expert system for all our water treatment plants, whether they are industrial water, wastewater, desalination, municipal water, wastewater. So we're bringing forward a product called as AI Operator Coach, which is a digital support at our decision expert system for the operations. We all understand that there are multiple difficulties that are kind of there, and our teams are actually managing those in real time, right? We have been engaging with a lot of plants across the globe, from Canada to North America to Southeast Asia, India, Middle East, and we have understood there are majorly three challenges that water treatment plant operators or owners are battling with. The first one is on the operational side of day-to-day engagement that they are doing with the plant, right? So they don't have a kind of real understanding of what is happening in the plant. There are some kind of suboptimal kind of issues that they are trying to improve with multiple technologies that are available handy for them. They are trying to kind of do better performance reporting in order to kind of tackle better kind of overall aspect of the plants. The second major pillar in which the kind of our operators are and kind of plant owners are challenging are from a maintenance perspective, right? There are a lot of challenges in the scheduling or the unplanned downtime that are coming. We understand that a lot of kind of these plants have reactive maintenance, or rather say scheduled maintenance. They don't have real-time insight of what is happening in their plant on a day-to-day basis, so that they can have a kind of better understanding of what's happening in the plant and can make early interventions. This is where I guess a lot of plants are kind of actually trying to optimize their operations on. And last but not the least, kind of increasing the kind of compliance risks and the associated fines that come along with it. Multiple industrial facilities, municipal facilities are trying to improve their exceedance, right? They're trying to kind of bring more solutions into the place so that they can have more kind of compliance knit exceedance issues that they are facing. And this is where Pani Energy come in, and we solve all these three major challenges and the peripheral kind of problems that our operators, process analysts, fleet managers, and owners of the plants are facing. In order to solve that, we bring forward, as I said, a decision support or a decision expert system, which we call as AI coach or AI operator coach. This is a software service that we bring forward for all our kind of plant owners and operators, which is bundled together with leading technologies like artificial intelligence, machine learning, cloud, and IoTs. All of these bundled together and is available for all our users in a subscription. It is as simple as using Netflix, Amazon Prime, or Hotstar today, and we offer this in very low risk and capex friendly business model for our users to not invest anything upfront, but use it as a monthly service or a yearly service as they seem fit. By AI coach, the water treatment plant operational teams are now able to kind of have more reliable operations. They're able to optimize their risk. They have better predictability in their operations. They are able to know what is going to happen in the plant in the coming hours or coming days, so that they can plan well ahead in advance and obviously optimize the overall performance. Right. So, and all of this, as I said, is available in a subscription model, which our operators and plant owners can adopt. Now, our AI technology is very, very purpose built for water treatment. Pani Energy as an organization does not provide their technology into any other industry. We are very, very focused for water treatment and majorly in three major applications. First one, industrial water, wastewater, whether it is process, food and beverage, pulp, paper, etc., or it is ETPs, we are catering to both of those. Desalination, municipal water, wastewater, both in WWTPs as well as STPs, we are catering to all of these applications and have customers live in all of them. Now, just a very quick snapshot. Pani Energy is a Canadian organization which kind of got spun out of 6+ years of R&D and more than hundreds of plant visits and interviews, sitting with the operators and maintenance teams and process analysts to understand what's actually happening in the plant and how they are trying to solve these problems. What could be done better around it, right? We came into operations, commercial operations in 2018, and since then we have been awarded across the globe and have been kind of recognized by a lot of players in order to the technology that we are bringing kind of it to life in multiple plants. So from global water intelligence to very recently, we have been named in top 100 companies around the globe in clean tech space by Global Clean Tech Program, and we have been kind of awarded by Suez, PUB, and kind of been adopted by a lot of these players that I'll talk about as we go forward. Now let's get into the crux. How does all of this happen, right? So it happens in 4 simple steps. Whatever stage your plant is in, whether you are running manual operations with manual logbooks, or you have sensors, PLC, SCADA systems, or DCS in place, whatever is your digital maturity or whatever is the digital maturity of the plant, we engage with you on that particular moment. So we collect the data from your existing ecosystem, digitize it, and take it to the platform where it runs through Pani's proprietary models. And all of that proprietary models start giving you real-time actionable analytics, alerts, and notifications, which then the plant's operational staff or the managerial staff or the process staff has the opportunity to take those recommendations and make an action. Now, make an action is very, very key here, where we act as a decision expert or a decision support system. So Pani won't ask you to change your control narrative. You can still continue to operate your plant today as the way you want to. So in case you are a PLC based control narrative, you can continue that. If you have SCADA systems, you can control your plants like that. In case you're doing it manually, you can continue to do that. Pani would give you actionable analytics and recommendations for your operators, process analysts, maintenance staff to kind of take those actions with data backed decisions, and obviously kind of have the leadership and the fleet owners or the area sales managers which are managing multiple plants have a real-time pulse what is happening with the customer, and they can intervene well in advance to kind of retain that customer or improve the overall experience for that particular customer. Now kind of expanding on kind of what actually how it looks like and how our customers are able to actually use it. It's a web-based platform, so there is nothing specific that you need for it. It could be used on any kind of device. You can use it on your normal laptops, your PCs, your mobile phones, your tablets, whatever mobile phone you're using, Android or iOS. It is device agnostic, and in case you have this device and you have internet access, you will be able to access and use AI operator coach. Rephrasing, how do we actually use it? So if you, let's say you're using some sensor readings, you have a couple of sensors in the plant or multiple sensors in the plant, or let's say SCADA or a PLC, we fetch all of that data from there, take it to the platform. There is parallel or only manual entry in case you're using manual logbooks or lab tests or others. All of that could be fed and digitized through our platform in a very intuitive way. All of that goes into the AI operator coach, where AI operator coach starts giving control suggestions or actionable analytics to the operators or managerial staff, which then have obviously an opportunity to take that action and control the plant through your existing control narrative. Now, when you're doing this, what exactly are you getting out of it, right? So we give a lot of different values which are used by different stakeholders that are present in the plant. A few of these might be used by operators, a few of these might be used by both operators, site in charge and process analysts, and a few of them only through the leadership and the executive team, right? So we give around set point recommendations, we give real-time alerts and notifications of what's happening in the plant, what is going to happen in the plant. We give you predictive insights in terms of this is the problem in the plant, why this is happening, what is the impact of this particular problem that is going to happen in the plant, as well as what you can actually do to solve it. So it not only is identifying the problem, but it is also kind of going into a root cause analysis and giving you a prescription of how to solve that. In parallel to that, it is actually mapping all your key performance indicators, giving you all the kind of performance metrics on a click of a button to understand and what's happening, give you real intuitive dashboards, access to all the historical data. So from the day you subscribe to the platform till the day you have access to the platform, all your historical data is there in the platform and can be downloaded or printed on a click of a button, right? So you can build all your reports. And when I say build reports, these are automated reports. So you can build a report, configure a report, all of these reports on a regular basis, whether it is daily, weekly, monthly. Platform will compile those reports, generate those reports, and automatically send those reports to respective stakeholders that you would want to. So you don't have to build the report, you don't have to download the report, and you don't have to send the report. All of that gets automated from the plant. And by all of that, Pani brings forward a digital twin of your water treatment facility. Okay. Now, there are a lot of kind of our customers that confuse us that we are going to recommend a change in hardware, we are going to recommend a change in process. No, we completely work with your existing systems, whatever you have. In case you are not using any digitized systems, we have a kind of tier or a level available where a lot of our customers are actually feeding manual data and kind of are leveraging all of these benefits out of it, right? So Pani AI Coach actually comes on top of your existing technology, whatever you are using, and kind of starts giving you more prediction, more understanding of your data, so that you can optimize your operations and kind of take decisions well in advance and accurate. Now, in terms of, as I was explaining, it's a web-based platform. It is designed keeping in mind the different roles that your various stakeholders have in the plant, right? So you have your operators, you have your site in charge, you have your process analysts, you have your plant engineers, you even have your executive and the sales teams, which are actually managing a lot of your customers. So this platform is actually defined and designed in a way that all of these stakeholders get the access to the relevant data that they are looking forward to. A few of these data that maybe executive team might not want to go a very deep in kind of process that a process analyst might. So the overall platform is designed in such a way so that all of these stakeholders are able to use the platform in a very intuitive and kind of get all the information and decisions as and when they want, right? So all of the time sensitive issues, whatever is happening, whatever is critical in the plant, is actually going to the operators or the stakeholders in a real time basis through on the platform, through emails, through SMS. The weekly intels that these stakeholders might need, or the executive team might need, or the process analysts or plant managers might need, all of that is automatically compiled by the platform and automatically sent on a daily, weekly, or a monthly basis. These could be metrics based reporting, it could be even graphical based reporting, whatever you are looking forward to. And even there are performance reports that actually keep coming to the operators and relevant stakeholders in order to kind of have more process control, more optimization of the overall performance of the plant, in order to know when to, maybe example on the screen of a membrane based plant, when to clean your membranes next. And it does not only kind of give you a recommendation of when to perform the CIP, it would even go in detail of what to do in that CIP, whether you should clean, flush, replace, whatever you want to do, and exactly with the set points and recommendation of what would the soak time, what would be the cleaning time, etc., etc. So it will go in deep and kind of give you those insights for you to take better decisions and optimize your overall operations. Now, all of us understand that not all the customers or not all of our plants are at the same digital or operational maturity. A couple of our plants are actually very, very high end. They are well instrumented. They are using DCS and SCADA. There are good team that are actually optimizing the plant with their wisdom and their experience. However, there are still thousands of plants out there which still are not using sensors. They're running on manual data entry. In case they are using sensors, they are not doing it remotely and they're not optimizing the process. It might be only connected to an HMI where they might be able to see when an event has already happened. They don't have any predictability into the ecosystem. So what we have done is we have broken AI operator coach into 2 segments and 4 tiers that are available depending on the digital and operational maturity of your plant. So you can start from the bottom and slowly and gradually upgrade your plant to the larger tier to get more value out of it. So there are 2 segments in which we categorize these value is measure and optimize. So let's start with the measure, where whatever your plant is, in case you want to measure your or what's happening in the plant, what is happening, when is happening, you want to have that understanding across your fleet of your plants centrally, you would want to go for measure. If you want to understand what's happening, if there is any issues to be reported to somebody who is not on the site, through an SMS, through an email, all those alerts coming in real time, reports getting collated, compiled and generated in real time, all of that is happening in the measure category. Now within measure, depending on how your operations are, if they are manual, we would recommend to kind of go with starter, where if you are using pen and paper or Excel sheets, we digitize all your process and you are able to kind of use it in a very, very intuitive, with alerts, with automated reports, and you can go ahead and use this for any kind of plant. It could be industrial, municipal, desalination, STP, MBR, SBR, membrane blend, RO, MF, anything. And we have live customers across the globe as well as in India using this. The next tier within the measure category is base. So this is something, if you have, let's say, some sensors in place, but you're not able to remotely monitor different plants and guide your operators or your site teams accordingly in order to optimize the workforce as well as optimize the operations, this is where we recommend to go for base. In case you have these sensors, we come and plug the kind of a gateway along with your team and take all of that data, real-time data, to the platform, so that you are able to monitor not only one but multiple of your plants in real-time basis from a central location, and guide your teams, your operators getting real-time alerts, notifications, as well as your central teams, so that you can not only optimize your process, but you can also optimize your workforce and kind of have a real-time measurement, real-time pulse on across your operations. The next segment that we use is the optimize. if your facility is already using sensors, PLC, HMI, and you have historical data, you want to further optimize your overall operations. You want to overall further optimize the performance. You want to optimize kind of, let's say, membrane life. You want to optimize the overall kind of uh, in terms of cost. Let's say you want to reduce the cost in terms of chemical, in terms of energy, etc. This is where optimize comes in. So there is a qualifier in optimize. The optimized tier would need digital connectivity. So if your plant is manual, you don't have any sensors, we don't qualify the plant into the optimized category. So we would recommend the plant to start from the starter tier and slowly upgrade towards the optimized category, right? So Bright and Genius both would need real-time sensors into the system. So if your system have sensors and PLCs and all of this in place, you qualify for optimized category. And in case you have historical data, so for Bright, we would need somewhere close to 3 to 6 months. And for Genius, we would need from 6 months to 1 year of historical data, which we work with you, use that and start giving you actionable analytics. So we will be able to do automated anomaly detection, what's happening in the plant, why it is happening, and give you solution support, what you can do, what your operators can do in real time in order to solve these. We start giving you a lot of analytics in order to perform better CIPs, in order to optimize your cost, in order to have more effective CIPs in case you are doing those, right? So this is where we do Bright, and we bring and in the flagship tier that we have Genius, all of that we take one step ahead, where we start forecasting or kind of telling your operational team what is going to happen in future. So we start predicting that this is going to happen 24 hours from now, 48 hours from now, or a couple of days from now, so that your teams could be well prepared. They can take better interventions, they can make better decisions. This is where we kind of bring forward our Genius. And we also give set point optimization in terms of what flow rates, pressure, etc., various set points in order you can operate on in order to achieve your optimization goals. So we have seen different customers having different optimization goals. So for example, a few of our customers have the optimization goal of improving the water throughput, improving the water recovery, right? So if your goal is improving the water recovery, we will have all of those constraints and all of those compliances put in the platform, and the platform will give you the set points in order to improve your water production. In case your objective of optimization is cost, you are able to achieve the same water production what is actually needed. So you are able to kind of meet the demand, but however you want to reduce the cost by meeting the same demand. This is where we set our models accordingly, and you start getting kind of set points in order to achieve the same water throughput or production, but at less energy consumption or less chemical consumption through dosing and etc. So this is how we have structured our overall product. It's one single product, but depending on the digital or the operational maturity of the plants and your teams could select which tier to start from, and you can upgrade on a click of a button if you qualify for the upper tier, and you can move. There have been plants in India and in globe that have directly started using Genius because they had all the sensors and historical data in place, and they qualified for Genius directly. All of this is available on a monthly subscription, and you can kind of subscribe for that and kind of start using the platform in a kind of intuitive manner. Now, in terms of a very quick run through in terms of case studies, I have kind of highlighted 3 different case studies, and I'll go in depth in only one of them in order to kind of keep it short, but anybody is interested, we can take them separately as well. So the first case study that we are talking about is reducing the overall operating risk. I will go in detail in this one. This is one of the 6 MLD plant of industrial UFRO, which is being operated by one of the top 3 water treatment service providers across the globe. We were able to kind of achieve more than $160,000 of saving over 2 years for this particular customer. It is a 6 MLD plant using a river feed for boiler feed water in northern USA, and we were able to kind of detect 38 unique events which their process teams didn't detect. And all of this particular plant is actually using a SCADA systems in place. So these issues were not detected, and our AI algorithms were able to detect those and give those value to the customer. I'll go in detail in depth. We have been been used in a desal facility where kind of a customer in industrial desalination kind of customer has been able to use us to in order to improve the water recovery as well as lower the overall energy consumption by 6% and improving their water recovery by 12% in a 6 mld facility, and it's a seawater RO facility in Southeast Asia. We have been also been used by a larger industrial ETP, industrial wastewater site, which is actually a paper mill effluent treatment site of an Indian customer, but their facility is running in Canada, and we are running a couple of their plants in India as well. They were able to they were using activated sludge and kind of anaerobic digesters. We were able to overall reduce 12% of their cost in their overall OPEX. We were able to reduce their consumables. We were able to kind of give them more better prediction so that they were able to kind of prevent a downtime event and able to kind of comply with the risk and overall operational safety. Now, going a bit in detail in the first case study, where it is actually this is how the overall plant looks like. It is using ultrafiltration for pre-treatment and using RO for treatment. It has a river feed brackish water intake from an overall perspective. We were able to kind of save somewhere close to $160,000 for them in a span of 2 years. We were able to kind of have them 30% more successful and effective cleanings. We were able to kind of give them 38 unique events which their team or their existing capabilities were not able to detect, so that they can prevent these problems from happening and kind of take those actions. And this is how the customer actually optimized overall. We were able to actually predict a particulate fouling event, and we were able to kind of well in advance tell them that this particular event will be particulate fouling well in advance. We were able to separate it from biofouling and scaling, and we were able to kind of tell the customer exactly that this particular event is going to happen in couple of days, and it would be a particulate fouling event, and what you could actually do. So we were able to kind of tell them that you need to check your SDI and kind of ensure that they stay below this particular membranes, and we were able to kind of predict them when to service and which membrane to service in order to have this. In last 3.5 years of operations, we have been actually adopted by a lot of customers in Canada, US, Middle East, Southeast Asia, India. We have almost close to 5 to 10 customers running in India today, and we are looking at somewhere close to 20 plus customers getting onboarded in India by end of this particular Q2. Right. So we have been if you see, we have been adopted by some leading brands in the water treatment space. We have kind of received a lot of testimonials from some global players. We have been kind of used by food and beverage, from pulp and paper kind of organization. We have been recently adopted by the Abunyan Holding in Middle East, which is actually a parent company of Vetico, Nomac, and Torre. So we have been kind of getting adopted and getting recognition across the globe from the kind of capability that we are actually bringing forward into the ecosystem. Now, just to kind of summarize, what do? We are trying to solve or kind of bringing forward a decision expert ecosystem standing alongside your operational, your maintenance, and your process analyst teams in order to solve 3 major things. We bring more reliability into your ecosystem in order by mitigating your risk, help you extend the asset life cycle that you're using today, and reduce the overall OPEX in terms of maintenance cost, in terms of energy cost, in terms of chemical dosing, etc. All of this done by seamlessly a subscription-based monthly payable software AI operator coach from Pani Energy. It's a cloud-based solution, IoT and AI powered, used for plant-wide remote monitoring and optimization. It helps you get the data centralization and advanced reporting. You can have your user-defined roles, KPIs, alerts, and analytics on the go, automated daily, weekly, and monthly reports. It needs no disruption and no retrofit in terms of your existing setup. there is no additional or maybe a very, very minimal sensor or instrumentation required depending from a site to site. This could be used for sites which have manual data entry, or could be integrated to the sites which have existing sensors, SCADA, and PLC. In case you would want to know more, please book a demo through our website and we would be happy to engage to you, or maybe you can feel free to write to me, and more than happy to talk to you, understand your challenges and your problems from your plans, and happy to collaborate. Thank you.
Jatin. Thanks for giving us a peek into the digital future for the water and the wastewater plants. We know how technology or digital transformation is happening in the other sectors. And I'm sure that, the water and the wastewater sector will see it too. So let me quickly take a few questions, Jatin. We have Sanjeev Sinha. He's asking a question: how does the platform predict the operational performance for different types of ETP processes?
So we have built different kind of algorithms for different kind of systems already. So membrane kind of based plants for activated sludge and other facilities, we have already built the algorithm. So in the start, when we are configuring your platform, we understand what your process is. So it is fused with historical data as well as real-time data that your sensors or your teams are feeding, bundled together, and all of this data is actually going into the platform, which is running thousands of simulation using machine learning and deep learning algorithms, and kind of giving you recommendations or set point optimization in order to kind of achieve that set point in order to improve your performance.
Okay. A follow-up question from Sanjeev is that typically effluent characteristics change over time with process variations. Now, how does your platform recognize these changes?
Great.
Which is happening in a manual system.
Okay, so see, artificial intelligence is actually based on data, right? So if you have a manual system, and let's say you have on a daily basis or a weekly basis or a monthly basis, whatever your water quality ecosystem is, whatever you are feeding, the kind of system would get that. But as I said, the optimization is not dependent on manual data, right? So if your plant only has manual data, we would not recommend you to use kind of optimized category rather than use meta category. But in case you would have pH, TDS, conductivity kind of sensors already in place, if you have all of that place and you are feeding, let's say, water quality analysis on a weekly or on a monthly basis, whatever is your ecosystem, even in a quarterly basis, the algorithms will be able to get tuned to it, learn from it, and be able to kind of give you recommendations.
So Jatin, a question is a person anonymously has asked is, what is the accuracy level of your predictions?
Great. So we have worked with kind of top 3 water treatment service providers across the globe. We have been able to, there's a case study available on our website, a detailed case study of 3 to 4 pages, where we have been able to show that from 90% to 96%, we have been able to predict that this is going to happen in your plant with accuracy. We were not only able to give the accuracy of the existing events that their other solutions were also kind of recognizing, but we were able to find extra events which the other existing solutions today in the market like SCADA and others, or their teams, the process analyst teams, were not able to provide, and we were able to give those recommendations as well.
So Shriram Bhalerav is asking this question: do you have a panel of process experts to recommend the improvement of operational protocols, or do we have to give these inputs?
So we already have a panel of experts, and all of that knowledge is also fed into the algorithms already. So as I said, we have different algorithms for different systems. The only thing that you have to provide is only one time when we are setting up your plant. So we would want to understand your PNID and get some historical data from you, depending on which tier you are using. So if you're using Bright, 6 months of operational historical data. If you're using Genius, 1 year of historical data, and then real-time data. So you don't have to give us the process experts. We already have that bundled in within the platform.
So Manas Dalvi is asking this question: how feasible are the algorithms if applied for different wastewater streams? I mean, you have textiles, semiconductors, I mean, different types of wastewater streams?
So we are already kind of being deployed for different wastewater and ETPs in different industries. So for example, pulp and paper is using us very recently. Fabric is starting to use us. Food and beverage, different players are actually using us. So the overall algorithms are actually dependent on the process, and we have built those process. Obviously, the data that these particular plants would give are different, and algorithms are capable of getting tuned to that data set and start giving those operational recommendations accordingly. So it is very much feasible for different industries, and we have proven that already in the market.
Okay. Ajay Popat is asking this question. If you have a multiple manufacturing plants, do we have to buy one subscription or multiple subscriptions? That's first part of the question. And the second part of the question is, what are the ballpark subscriptions for all 4 different conditions, that is operating manual, semi-manual, and automated completely?
Okay, so let me answer the first one. So our subscription is based on the plant. So if you have, let's say, 5 plants, you will have to buy 5 subscriptions. However, you can monitor all your plants on a single screen, and your respective stakeholders that are dependent on that are responsible for that one single plant can go in detail. But your central team sitting at one place can monitor all your 5 plants on one single screen and get to know what's happening where. But you have to buy separate subscription for separate plants. But in case you are an O&M service provider and you are operating 50, 100 plants, we can kind of deep dive and we can see how we can optimize that kind of commercial engagement. Now, in terms of commercials, how it look like, the commercial are dependent only on 2 things: the size of the plant and the tier of the product you're using. So for example, the starter version, so for any plant from starting from 250 KLD to 500 KLD, 1 MLD, 2 MLD, you can access this at somewhere close to 3,700 INR per month. Unlimited users, unlimited reports, unlimited alerts, no restriction from our side. So it keeps growing depending on the capacity of the plant. So it starts from 3,700 for starter, somewhere close to 7,000 from base, and keeps growing for the other tiers. And we can go in deep dive. You can reach out to me and we can go in detail on that.
Okay, there is a following question from Ajay. He is asking, can we host the app on our company server?
Not exactly today, because because we have our proprietary technology on of that, but we do have those questions coming in from different customers, and we have a lot of security policies. If your concern is cyber security and data privacy, we have already kind of addressed that with multiple leading customers across the globe, and we will be able to address that with you as well in case your challenge is cyber security and data risk.
Okay, Sajid Shankar is asking, for any real-time analysis, sensors play a very important role. So does the algorithm predict wrong sensor reading or sensor calibration reading?
Great question. Yes, we do. So our algorithms are kind of able to differentiate between a calibration issue or a real-time challenge that is actually happening in the plant. Right. So, and we have done it with multiple customers where we have actually given a recommendation to the customer that, hello, this is what is the problem looking like. And we feel that this is a data entry or a sensor calibration issue. Please see it. If this is not the problem, this is the problem. Please look into detail. So yes, we are able to differentiate between sensor calibration issues and real-time problems that are happening.
Okay, Sham Chaudhary is asking this question. How will the early verifications of biological load on the STPs be accounted for in optimization if the plant is manually operated? And what is the ROI for a manual plant?
So I would again reiterate that for manual plants, I would recommend not to directly kind of aim at the optimized version, right? Or rather than start from the measure version and slowly, if you have historical data, move to the optimized category. If the data frequency is low, optimization ROI will be lesser, which is why we don't recommend our customers which have manual data entry to use optimized category. rather than if you have manual data entry, there is a lot of value that our customers are seeing through optimization or of the overall operations that we are able to give them.
Okay. Arsh Anwar is asking this question on how much data are your models trained on, and is it learning real time? That's the first question. Second is on how many factors are you considering for the training data, and can you name them?
So already the models are like very, very strong. So for example, if I have to tell you, if RO and UF, like we have years and years of data being trained, and not only on one single provider. So if let's say you are using kind of Suez membrane versus a film tech membrane versus a hydronautics membrane, we have data for that. We have trained those models. We know their performance, not only on membranes but pumps and other equipments as well. So there's years and years of data available. Yes, they are learning real time. So let's assume we have a similar plant in India today, and there is a plant similar in some other part of the world. If a similar event is happening there, why we recommend to use our servers? Because if we are making a learning there in some other place of the world, and you have a similar process or you have a similar plant, we will be able to give that recommendation and give those learning and optimization to your plant as well. So it is, yes, learning in real time. There are multiple kind of factors in which the models are learning. So we are using different techniques like deep learning, machine learning, first principle, and physiochemical models. All of this, we call it as hybrid AI. So but in terms of different, we actually recommend, so for example, let me take an example of RO. We would ask you very simple sensors: pressure on feed and kind of concentrate or permeate, kind of flow meters, pH, conductivity, TDS. We won't ask you very high-end analyzers or such. Very basic sensors, if you have in place, we'll be able to give you optimization features as well.
Okay, a follow-up question is, are you taking hydraulic retention time in account?
Yes, the models are taking that into account, yes.
Okay, Ajay Popat is asking a follow-up question. Since we will be sharing, storing lots of proprietary design data with you, will you enter into a non-disclosure or confidential agreement, please?
100%. Every single contract that we sign already comes with a kind of confidentiality and NDA with us. Pani will never share your data with any third party or not use it for any commercial purposes. We, as by default, not only for you, every single contract we sign, that confidentiality comes in close, and we have even done third-party penetration testing and other security policies in order to secure your data, which is done regularly.
Okay, Montu Lakhani is asking, how do we calculate the cost incurred for your installation? Does it depend on per KB data, or is it a straightforward installation cost and per minute charges?
Great. So so for example, if you're using starter tier, we would not charge any implementation fee. In case your team is if let's say the first plant with you, we will 100% help you, but it is self-configurable in the starter tier only, right? In case your team is equipped to use any normal application like Facebook, LinkedIn, you would be able to configure the starter, right? It is as intuitive as that. But going forward, there would be one-time setup fee, and we won't charge you based on bytes, based on number of sensors, based on data. It would be one-time service fee of setting up the platform, and then a monthly recurring fee based on the capacity of the platform and for unlimited users. So if you can start with 5 users, going forward, you can add multiple users to the plant, and we won't charge extra fee.
Okay, Tushar Sheel is asking a question: for a 6 mld desal plant to reach to a genius level, how many sensors are recommended by you, and what is the learning time? Well, learning time, and in bracket he's mentioned AI.
Okay, so generally there is no learning time as such. The models are pre-trained. We just need to actually tune them to your local conditions, because the influent quality would be different. You might be using a different process or might have different equipments in place. So for the process of seawater RO or a brackish water RO, the models are pre-trained. If you have 1 year of historical data, we can consume that data, bundle it with real-time data. The only time lag that you have for setting up and configuring your plant, sitting up with your team, understanding your compliance constraints, we might take 6 to 8 weeks. if you by Q2 we will bring that down by 50% to 3 to 4 weeks. So setting up time is 6 to 8 weeks, but the models have learned it will, or if you have 1 year of historical data, it will keep tuning, and within 3 months you will start seeing the results.
Okay, Arun Kumar Agarwal is asking, do you have any standard questionnaire that you have for existing STPs and STPs for plant performance improvement? I mean, normally if you want to engage with them, is there any standard questionnaire you have?
We do have a standard questionnaire which we use to qualify the plant in terms of which tier it will fall on. So for example, we can share you a questionnaire asking what are the process, what type of data you have, etc., etc. But after which we will come back to you and tell that, okay, you qualify for genius, you don't qualify for genius, we can only give you bright. So that type of questionnaire is available, and we will be able to go in detail after that and tell you that, okay, this is what the optimization will be able to provide you.
Okay, Arsh Anwar is asking, which all ML or DL models is Pani offering? And can you tell us the architecture?
That would actually be our IP. So what we do is we are using from deep learning to machine learning to first principle models as well as digital twins. We have bundled all of those kind of capabilities together to build our AI operator coach. So depending on what's happening in your plant, the platform might be using a combination of deep learning and machine learning, or maybe using a combination of deep learning and digital twin, or maybe simulation, right? So depending on what we are trying to solve, not every we have understood in the market through our years of R&D that not every single performance or let's say problem could be solved through machine learning, right? There has to be a combination of ML, deep learning, as well as digital twin and first principle models, and we use all of that in order to give you recommendation. As I said, that there could be statistical models, there are physiochemical models. So, but going in details, those could be our IP that we're talking. But in case you're interested, we can have a more technical session with you so that you get a more kind of deeper understanding of what we are providing from a technological perspective.
I'll take one final question. Jatin, Mohammad Nazir is asking, typically, do you charge for a kind of a visit for discussions with your clients? Or so second question is, how much do you charge for the first visit?
We generally don't charge for the visit as such, right? We would we generally don't do a plant visit as such, right? Until unless like the customer is kind of sold on the value and they would want to proceed. The visit comes in the end where we kind of go and understand the exact process, right? But from an overall value evaluation or value fitment perspective, we can have virtual sessions and we can understand your problems. We can tell you that whether we are a fit for you or not, and we can kind of deep dive in those, not only from a high level perspective but deep technical and process perspective as well, but we don't charge for that.
So thank you, Jatin, for this wonderful session, and then patiently answering all the questions that the audience has put up. In fact, I would like to thank all of our presenters, both Jatin, Meni and Rob Sampson, thanking them for taking time out of their schedules and addressing the audience at the IWET series, or the 5th episode of the IWET series. So thank you once for all of you. And I hope you have found the session as relevant as our audiences have found it to be. Before we break for the session today, I just would like to share with you is that the next month on March 22nd, is the finale of the second season of IWET, series. And in that, we are doing an innovative format in which we are allowing our attendees to have one-on-ones, time with our presenters and speakers. So we will be sharing details with you about that session soon. And I would request you all that in case anybody of you wants to have any one-on-one sessions with the speakers, you can actually let us know in advance, and we would fix immediately after the webinar is over one-on-one meetings for you with the speakers that have been a part of IWET series so far. So with that, I would like to thank all the speakers one more time. We are beyond the scheduled time, and I would also like to thank all the attendees for patiently sitting through and learning from all the experts. So thank you once more, and with that, I bring this session to a close. Thank you.